More linear equations and writing linear equations from word problems and good fun things. So a line, y equals mx plus b. Remember, we have to have our m, which is our slope, also known as our coefficient of x, rise over run, and rate of change. We also have to have our b value, which is our y-intercept. It's also known as a constant because there's no variable attached, and it's also known as a starting point in many word problems. All right, so this time it's going to pass through a point 1, 6. I'm going to go ahead and label 1 as x and 6 as y. Then we see the word parallel, which we know is very important because parallel means we know something about their slope of this new line. And parallel, so that means we know slope is the same. And this is in slope-intercept form, so that's beautiful. So we can identify our b value. And our b value is 4 because that's our m. What is the value of b? And this is referring to our new equation. Remember, don't grab 6. This guy means nothing. So we need our slope. So we did m and we did b, and that's what we need for our new equation. Our m is going to be 4. So we're going to write our new equation. We do have a y value, and that y value is 6. We have an m value, which is 4, because it has to be the same as the other to make it parallel. And then we have an x value of 1. And we are missing our b value or our y-intercept. We're going to now solve for b. So our line of great divide, we have b. This is going to be 6. This is going to be 4 plus b. We're going to move that 4 by subtracting it to get the b by itself because he's attached to b. Minus 4. 6 minus 4 is going to give me 2. And b is now by itself. So we now have our 2. Now we have the 2 parts necessary to write the equation of the line because it's all we need. So y equals 4x plus 2. And the question said, what is the value of b? 2 is our answer. The answer to this question is 2. The equation that would be comparative is 4x plus 2. And those two lines would never touch. All right, word problems. The total cost in dollars of a membership at a fitness center is given by the function C of M equals 20M plus 40, where M is the number of months. So M is months. That's important. A person is a member. In dollars, how much is the cost of the membership for 1 year? 1 year is what we're looking for. So C of M, this is the same thing as Y. This is our output. That C is cost. And then our M is our months. So M, or our rate of change, is months. So don't get that M confused with our slope M. This is the M that is our variable. So M is months. Our rate of change, so our cost that will go up or down, in this case it's going to go up, is 20. So that's our slope or rate of change. Our non-negotiable is that 40. You're never getting out of that, also known as our y-intercept. And now it says, what is the cost of a membership for 1 year? They're coming for you here. 1 year because this is year, this is months. How many months are in a year? There are 12 months in a year. So now we're going to fill in our equation. So we have the C of M, which I'm going to just call it y equals 20 times 12, because it's 12 months in 1 year, plus 40. And we know that this goes inside the equation because it's a time, so it's months. Cost is your output, time is your input. So 20 times 12 plus 40 is going to be 280. So it is going to cost 280 for a 1 year membership. The cost is dependent on how long you remain a member, that X value, your input and output. All right, Eli, Ryder, and Derek went to Cold Stone to get ice cream after school on Tuesday. The function f of x equals 1.25x plus 4.75. models the cost of a scoop of ice cream with additional toppings, where X is the number of toppings. So X is our number of toppings. What is Y? Y is going to be the cost again. So knowing that Y is cost, that 1.25 is definitely money, and our 4.75 is also money. The 1.25 is going to be our slope or our rate of change because it's attached to the variable X. So depending on the number of toppings, it's going to go up. That's a positive 1.25 for every topping you add. Your 4.75, if you're thinking ice cream, is just a single scoop of vanilla or whatever you got. So this is your starting point, or in this case, starting cost. So as soon as you ask for ice cream, it's going to be at least $4.75. So what is the cost of one scoop of ice cream with no toppings? That's your starting point of $4.75. That's your y-intercept, right? So if you're graphing it, you go to the y-axis at 4.75, 4.75. So between 4 and 5, closer to 5. How much does each additional topping cost? This is our slope, because for every topping we get, it's going to cost $1.25. So now what is the cost of each person's ice cream? If Eli gets 2 toppings, so we're going to use our equation. So f of x for Eli is 1.25 plus we're definitely going to pay $4.75. In this case, Eli wants 2 toppings. So 1.25 times 2, which will give us $2.50, plus $4.75 is going to give us what? $7.25. So Eli's ice cream cost $7.25 because it was $1.25 per topping and he got 2. So Ryder's going to get 1 topping. So we're going to do 1.25 times the number of toppings plus $4.75. So times 1. So 1.25 plus $4.75 is going to give us $6. So Ryder's is $6. Derek is getting 5 toppings. He's getting all the goods. 1.25 plus 4.75. So what's the cost of Derek's ice cream with 5 toppings? And it's going to be $11. Oops, sorry, I just slid it way out of the way. All right, beautiful. What we could also do is if you have a TI-83, or you could also do it in your Desmos, if you go to your y equals, which is at the top, for some of you, you will remember this, we're going to do 1.25 x, which is going to be right here beside alpha, and then we're going to do plus 4.75. So we just put our function in. I don't know if you can see it very well. Like it's hard to read. There we go. 1.25x plus 4.75, and that's in the y equals. Then we hit second graph, and now we have a table. And we can go look for however many toppings they want. Mine is set to where it's telling me 0.5s, and you probably can't read these numbers very well. But again, it's y equals, put in your equation, second graph if you happen to get access to TI-84. Otherwise, you're going to go to Desmos, put in your equation, and then right underneath it, especially if you start it with an f of x, then we're going to use our function notation, and right underneath it, you can do f of 2, you can do f of 1, and you can do f of 5 in each line going down, as long as you put in f of x in Desmos with it, and it should just give you the answer right out. Last but not least, Maddie and Mackenzie went to the fair over spring break. It cost $20 to be admitted into the fair, where you would buy tickets to ride the rides. Each ride was 1 ticket. Tickets cost $1.75. What was the non-negotiable that they had to pay? As soon as they walked in the door, they had to pay $20, right? So that's our 20. And that's going to be plus, because we're looking at our cost. And then we're going to ride rides, which is going to be our unknown. That's what, when we get there, we don't know how many rides we're going to ride, but we're going to ride some number of rides. And if every ticket costs $1.75, that's what's going to change depending on how many rides we ride. That's the rate that it would change. That's our rate of change per ride. So we're going to pay $20 and $1.75 depending on how many rides we have. That will give us our output of our cost. Our X value in this case is number of rides. Our Y value, again, is cost. Most of the time, your Y value is cost or height. So it's the big picture that we're discussing. So if the girls each rode 5 rides, how much do they spend on tickets? The girls each rode 5 rides. So how many rides is that? They both rode 5. There's 2 of them. So it's going to be 10, right? So 10 rides. So 1.75 times 10 plus 20. What's the cost for them both to ride all their rides that day? It's going to be $37.50. Because Maddie and Mackenzie rode 10 rides. All right, what was the girls' cost of the fair if they only spent their money on admission and to ride 7 rides? So they only paid to get in and then to ride 7 rides. So Y equals 1.75 plus 20, because this is non-negotiable. The only thing that's up for debate right now is how many rides they rode. In this case, they rode 7. So 1.75 times 7 plus 20. It's going to give us 32.25. Ow, sorry. 32.25. All right, guys, hopefully you're starting to see some pattern in these word problems. Please reach out. Please leave me a message. Please let me know what I can do more of to help you.